Today we're solving problem 24 from the Spring Amc 10A from 2021. The interior of a quadrilateral is bounded by the graphs of x plus ay squared is 4a squared, and ax minus y squared is a squared, where a is a positive real number. What is the area of this region in terms of a, valid for all a is greater than 0? The first thing we can do is simplify these graphs. We can take the square root of both sides, so we get x plus ay is positive or negative 2a. And then similarly here we get ax minus y is positive or negative a. Let's just start with this one here. X plus ay is positive or negative 2a. There's two cases. First case, x plus ay minus 2a is 0. The second case being x plus ay plus 2a is equal to 0. Now what we want to prove here, we just want to find all the x-intercepts, the y-intercepts, and the slope. What interesting thing we see is that when we find the slope of this first equation, the slope equals negative 1 over a. Okay? Now, interestingly enough, when you find the slope for this one, you get the slope is also equal to negative 1 over a. That means these two lines are parallel. And the reason why there's two lines is because there's a positive and negative. So, we have this here. We're going to need that later, the parallel lines thing. But now let's see when we can use the parallel lines thing, if we can prove that this is parallel lines too. Ax, so ax minus y plus a is 0. That's the first case for this one. And then the second case for this one, ax minus y minus a equals 0. Okay, those are two cases. Well, what do you know? The slope of this one is a, and the slope of this one is also a. We don't really care about what the slope is, but we just care about that they are the same. And I found the slope because you can express slope in the form mx plus b, and then m is the slope. So you can just find m like this. I won't go over details, but that's basically how you do it. We have the same slopes here. Now we can use a distance formula to and put it on both of these graphs and multiply them together to get the area. And the distance formula, this is the absolute value of c2 minus c1 over the square root of a squared plus b squared for all equations in such that it's in the form ax plus bx something, ax squared plus a times x plus b times something plus a c that exists. And now we see that this is in the form that we wanted to, so we can use the distance formula. And this is the distance formula for parallel lines. That's why we can use it. Now, according to this one, this is 2a over the square root of a squared plus 1. I'm not going to write it as a square, but you can if you want to. It doesn't really matter. Same thing here. We use the distance formula. This is 4a divided by the square root of a squared plus 1. And notice I just moved this plus around. It doesn't really matter. But our area, well, what's the problem statement? Remind ourselves that we want the area of the region in terms of a. So when we multiply them together, 4a over the square root of a squared plus 1 times 2a over the square root of a squared plus 1. These square roots cancel. So what we're left with is 8a squared divided by a squared plus 1. This is going to be our area expressed in terms of a, and we are done.